Hi kids! Okay, welcome to another lesson. This is lesson 4 in module 3. So, as promised, I'm letting you know about some other stuff that goes on with fractions that I want you to keep fresh. So, yesterday we were talking about finding this scale factor to change from one fraction to an equivalent fraction. And so I had said it's kind of like finding the missing factor. So what times or 2 times what would be 4. So the secret there is whatever you multiply on the top or the bottom, you also do to the other, the bottom or the top. Okay, so the scaling factors here. So if I have 3/5 and I want to change it to 20/5, okay, and so the book will give you this number. Then you say, well, how do I get from 5 to 25? Well, 5 would be the factor. 5 times 5 would give you 25. Now, in this same way, you can work backwards, and so you can simplify fractions that have many pieces, and you can simplify them so that they're equivalent by dividing and going the opposite way back. So I could change 15/25 into 3/5 by dividing by 5. So I can take 3/5 and multiply by 5/5 and get 15/25, or I could take 15/25, divide both by 5, and get 3/5. So that's going to be something that we're going to keep talking about. Simplifying fractions. Here are some more notes just in case you want to see. Changing from 1/3 to how many sixths. 2 is your scale factor. What you do to the top, you do to the bottom, or what you do to the bottom, you do to the top. The scale factor will always be the same number. That's what fractions are. It's a ratio from the top to the bottom. And if you want to have equivalents, they have to have the same scale or the same rate at which you are changing both the parts. There is another page of notes. When I say simplify, what I'm talking about is we're going to take a fraction with many parts and we're going to make an equivalent fraction with equally fewer pieces on the top and the bottom. So for example, I think yesterday we had one like this, or on the previous lesson, 22/24. So how are these numbers related to each other? And that's that ratio part. So both numbers are even. This is that rule 2 that I was talking about, Mrs. Sednis's rules for simplifying. Rule 1 was look for that doubled. It's doubled from the top to the bottom. I know that's not probably mathematically correct, and I don't care. That's how I see it. So you have to come up with something that works for you. This is not a double, but they're both even. And so if they're both even, all numbers that are even are divisible by 2. And if you don't know any other factors or multiples of this number, then start with 2 and start dividing it and simplifying it until you can see another factor and simplify your fraction then. Now that's not even the beginning of lesson 4. Here's lesson 4. Lesson 4 is to add fractions with sums between 1 and 2. That means we're going to end up with potentially improper fractions. And the improper fractions are the ones with the big old noggin and the little, like, oh, heaven help me. Okay, it's really large on top and it's small on the bottom. It doesn't quite fit. It's like a wobbly fraction. So instead of having a wobbly fraction, make it a mixed number with a whole number, the leftovers out of the number of parts that we're counting by. So these are some of the problems that are in the teacher's guide, and hopefully your teachers will go over this with you to prepare you for the lesson. And just to remind you real quick, if you have an addition problem with fractions and they do not have matching denominators, you must make them match before adding or subtracting. This one started out as 1/3. It was 1 here, another here, and another here. And then 1/4, remember from lesson 3, horizontally 1, 2, 3, 4, shade 1. Then you lay over the pieces on the opposite fractions. So put fourths here and thirds here. And voila, you have equivalent fractions. 1/3 is equal to 4/12, and 1/4 is equal to 3/12. And then you add. Now today we're going to have bigger numbers for our sum. And so we're going to end up being able to fill an entire box. Now remember when I showed the teacher's guide, it says, hey, if you don't understand this concept, cut this out, place these two pieces right here, and see that it is 10/10 plus 3 more. That's where you would get the 13/10. So all of this is just to kind of help you get set for lesson 4. It's all kind of the warm-up that you would hopefully be doing in class before you start this lesson. And again, make equivalent fractions, add, and then straighten it out into a mixed number. Okay, into the book. Alrighty, focus. There we are. For the following problems, draw a picture using the rectangular fraction model and write the answer. When possible, write your answer as a mixed number, so don't leave it wobbly with a big top. 2/3 plus 1/2. Make a model. Remember that the first one is vertical and the second one is horizontal. Okay, 2/3 are shaded, 2 are shaded out of 3, 1 is shaded out of 2. Now I need to have equivalent fractions because I can't add these, they're not the same. So let's lay over the halves on this one and the thirds on this one. Now I have 4 out of 6 and I have 3 out of 6. And now I can add because I have like parts. So 4 plus 3 is 7/6. Now, when I have the opportunity to make a mixed number, I will take it. This is really a division problem. 7/6 is 7 divided by 6. So 6 can fit into 7 one time with 1 left over out of 6, and that is your final answer. And then we have 3/4. I need to give myself a little bit of space here. Define your space. Oops, but without crossing out the problems. Okay, make another model. 3/4. So 1, 2, 3 will be shaded. And 2 will be shaded this way. I'm sorry if I'm going too fast. I have a time limit on these videos. I have to be very conscious of that. Okay, and then take the 3 and lay it over here, and take the 4 and lay it over here. 1, 2, 3. And then halfway, and then half the left half, half the right half. And just mathematically speaking, if you just see the numbers, remember that you can multiply the bottom numbers and you will get a common denominator. So our common denominator is 12. And then mathematically speaking, if you are doing the cross multiplying, you're going to go 3 times 3. That will give you 9. 9 are now shaded out of 12. And this one would be this way. So you go up and down, and it's 8 are shaded out of 12. Okay, so mathematically, that's what you're doing. And in a model, this is what you're doing. Now, when you add these two, 9 plus 8 is 17 over 12. And this is more than 1. Remember, 12/12 is 1 whole. So how many past 12/12 are you? And you would say, well, I'm 5 over 12. So 12 goes into 17 one time with 5 left over. Hopefully that wasn't off the screen the whole time I was working. I tell you, so many things to think about. Okay, 1/2. And 5ths. 1, 2, 3, 4, 5. 1 is shaded. 3 are shaded. Remember, don't take forever on those things. It's not art class. We're going to lay over 1, 2, 3, 4, 5. And halves. And so now we have tenths. And now we're going to show our equivalent fractions. And so I used to have 1 out of 2 parts, but when I put 5 over the 2, now I have 10, and I have 5 out of 10 parts that are shaded. Okay, so look and think about what you're doing here. I have 10 parts here, 2, 4, 6, and again, 2 times 3 is 6, 5 times 1 is 5. I get 11 tenths, and that makes 1 1/10. Huzzah! Love doing these. Okay, and then also in the past, what I have done just to kind of show kids like what's happening, you can take these pieces and just go, okay, this goes here, 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 and now I have used up, this is all full, and I've used everything up except this one. And so this one didn't get to go. But this is now 10 tenths plus 1. That's 11 tenths. So that's just yet another way of looking at these. 5/7. Ooh, that's awkward. 1, 2, 3, 4, 5, 6, 7. Okay, just got lucky. And 1/2. 5 out of 7. 1, 2, 3, 4, 5. Sometimes I do one at a time. Sometimes it's just easier to do the whole pack. And then 1/2. And I need to make halves here and sevenths here. 1, 2, 3, 4, 5, 6, 7. Kind of squeezed it in there. But how many pieces do I have? It's 7 times 2. We now have 14 pieces in both so that we can create the equivalent fractions. And 2 times 5 is 10, and you can count them 2, 4, 6, 8, 10. So many different ways, and you can know that 7 times 1 is 7, or you can count them. It's really up to you at this point. So 10 plus 7 is 17 over 14. And I can fit one set of 14 14ths in, and then there are 3 left over out of 14. So pretty cool. Hopefully you guys are all understanding this concept so far. Then we'll do the next page, a couple of them, and we'll do a couple word problems. All right, 3/4 plus 5/6. I know it's a little blurry, but it will focus at some point. I am confident. I have confidence in me. What is that from? Name that movie. The Sound of Music. You're right. And 6ths. So halfway, and then 1, 2, 3, and 1, 2, 3. 5 of them. That's a lot of shading. Just gonna go all the way down like this. Shade it all. Okay. I need common denominators. Okay, so we're going to get to the point where you can have a lower common denominator. The lowest common denominator between 4 and 6 is 12. And I'll show you how to get there on another lesson. There's a little bit more process, and I'll have some notes for that. But for now, let's just use the strategy that we're working on. So lay over the fraction pieces, 6ths here and 4ths here. Because what's going to happen in some of the lessons to come is that these are going to get so many pieces, you'll be like, OMG, please don't make me do that area model again, because now I have 96 pieces. And I will say, yeah, I wouldn't want to do it either. So, okay, we have 24, because 6 times 4 is 24. So out of the 24 pieces, how many are shaded now? Well, it's 1, 2, 3 times 1, 2, 3, 4, 5, 6. 6 times 3, 18. How many are shaded here? 1, 2, 3, 4 times 1, 2, 3, 4, 5. And that's 4 times 5. That's where those numbers are coming from. And then we have 18 24ths plus 20 24ths. And so we're going to have a pretty big answer. That is 38 24ths. So you can't leave it all big and awkward like that. So we'll just put it below. And what's the difference between 24 and 38? I could fit one whole set of 24, and there are all of 14. Oops, not 114. All of 14 24ths left over. Now, when you get to a fraction that looks like it's supposed to be your final answer, but you notice, and I will probably keep asking you guys about this, do you notice anything? I will want you to simplify. I'm going to ask you to simplify if possible all the time. And I know this math program doesn't always require it, but I am always noticing but they're both even. You could have fewer parts and it would be equivalent. So I'm saying, hey, look for these things. These are both even. If you don't know any other multiples, start dividing by 2. And that's just for this part right here. Okay, so 1 is still there, but 14 divided by 2 is 7, and 24 divided by 2 is 12. And this is my simplest form. So if you're able, and as soon as you start recognizing that you can make a change, make the change. Make it simplified. This is simplified. Okay? This is not. This is okay. This is like this. This is how I feel. This is how I feel. That says it all. There you go. And all your teachers out there will feel the same way. So 2/3. 1, 2. Super scribble. Ooh, and then I'm going to rip my book up. So 7ths, always awkward when it's odd. 1, 2, oops, 3, 4, 5, 6, 7. Let's pretend they're all the same size. 3 are shaded. 1, 2, 3. And then lay over the opposing numbers. 1, 2, 3, 4, 5, 6, 7, and thirds. There you go. Now you have created 7 times 3, 21 pieces in each one. And you can find out how many are shaded by doing 7 times 2, which is 14, or multiply in your array here. That's fine too. And then 3 times 3, or count them. Either way, just make sure you're putting the right number with the right model. 14 plus 9, 23, 21st, and it's awkwardly large on top, so we're going to fit 21 into 23 one whole time with 2 left over out of 21. And when you have an even and an odd, unless this is a factor of this, you can't simplify it. Okay, let's see. Solve the following problems. Draw a picture and write the number sentence that proves the answer, like we've been doing. Picture, number sentence. Simplify your answer if possible. See, they're asking you to do what makes us so happy. Penny used 2/5 pound of flour to bake a vanilla cake. Oh my gosh, hungry. She used another 3/4 pound of flour to bake a chocolate cake. How much flour did she use altogether? Flour, flour. Same amount, pounds, pounds. That looks like an addition problem. Okay, so set it up, and then we need to make a model. 2/5. 1, 2, 3, 4, 5. It's kind of awkwardly big, but oh well. And 3/4 across, across, across. 3. Okay, lay the 4ths over. 1, 2, 3, 4, and lay the 5ths down. 1, 2, 3, 4, 5. I'm not quite getting those straight. Anyway, how many 20ths do we have? Because it's 5 times 4. So 4 times 2, we have 8 here. And then 5 times 3, we have 15 here. And 8 plus 15, we have 23 20ths. And this would be 1 and 3 20ths. What? So pounds, LB, flour, not WEROUR, that's the food stuff. And almost done here. Last one. Great. Doing great. Doing great. Hanging in there. Isn't this fun? Don't you love these? These are really fun. Carlos, hi Carlos, wants to practice piano 2 hours each day. He practices piano for 3/4 hour before school and 7/10 hour when he gets home after school. How many hours has Carlos practiced piano? How much longer? So 2 questions, watch out for the question marks. How many hours has he practiced so far? How much longer does he need to practice before going to bed in order to meet his goal? So let's take our 3/4 and our 7/10, and you can make your model. And 1, 2, 3, and 7/10. Whoop. Okay, now this is going to be 5 on each side. 1, 2, 3, 4, 5. You can make your blocks bigger. 1, 2, 3, 4, 5, so you can squeeze them all in. And I don't want 3, but I do want 7. So I'm going to just scribble wildly until I get to the bottom here. And then I'll be really careful. Okay, now this is going to be one where I'm going to sneak in a little lesson about how to not have 40 pieces. I'm going to show you both ways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a lot, isn't it? It is. It is. It's 40 pieces in each box, and it's hard to count, and it's all scribbly, and it's all messy, and oh my gosh, Miss Dennis, I don't think I can do this. Well, I'm telling you, you can. And so one of the strategies to find a lower number of pieces, you're going to do what's called skip counting. Okay, so you would multiply by 1, and you can put the 1 here, or this can be the times 1, and then you can do times 2, times 3, times 4. And what we're going to look for is a match. So I always start with the bigger number because I am thinking in my head, match 4 multiples. So I go 10, 20. Is 20 a multiple of 4? Oh, well, you know, I kind of think it is. 4, 8, 12, 16, oh yeah, 20. Look, they match. If they match, this is what's called the lowest common denominator. And you can find it by skip counting. And so instead of using 40, I could use 20, and I'll use it after I finish this problem, and then you'll see how it goes. But for right now, what I want to show you is the math part. 10 times 3 is 30. There are 30 shaded here, and 4 times 7 is 28, and there are 28 shaded here. So if you had to count up all those pieces, you would have 58 shaded out of 40, and that's just a lot. So I don't really enjoy using these. What you end up with is I can fit a whole 40 plus 18 more, and then I have an even fraction here that I would have to simplify. And if you don't recognize any multiples and they're both even, you can simply start dividing by 2. And 18 divided by 2 is 9, and 40 divided by 2 is 20. But don't forget, you also have a 1 and 9/20. So this is how much has been accomplished so far, hours so far. Okay, that's one question. But the goal is 2 hours each day. And so we're not quite there yet. And so if an hour, remember that you can make a whole number out of any number. And since we have 20ths right here, 20 20ths equals 1 hour. That's 1 whole hour. Okay, so I have essentially 20 20ths plus 9 20ths. And he needs to have 2 20 20ths. So what are we missing? We need to have 20 20ths minus 9 20ths to find what's left to meet his goal. And so 20 minus 9 is 11, and that would be, it's way at the bottom there, 11/20 hours left. Okay, so then just real quick to do the 3/4 plus 7/10, if without the model we just did 20, this is where you go, okay, find the missing factor. 4 times what equals 20? 4 times 5. This is now my scale factor. So 3 times 5 would be my numerator. And then this one, how do I get to 20? It's times 2. So 2 is my scale factor for the second one here, and I would get 14. Now 15 plus 14 is 29, and I end up with 29/20, which is 1 9/20, which is exactly what I got here. And that's why a lot of people will just do it this way. But for right now, we're just working on the models, and this is kind of a sign of things to come. We will work on this in the future. But for now, 40ths are fine. Just try to simplify it into this answer and then how many hours are left. So I sure hope this video is helpful. I hope all my videos are helpful. And if they are, click subscribe and you'll be notified when I put more videos up. And I hope to see you on the next one. Have a great day.